Okay, welcome back everybody to day 12 of our inspection. Sitting here at sunny Kendallville, Indiana, where they have a full range of services here. So today we're going to be looking at the avionics and instrumentation. But before we get into that, I wanted to discuss a little bit about the issue yesterday of the overamp because of sitting on the ramp for an extended period of time with all of the electrical instruments, lights and whatnot on. So what happened was during that time it's just draining the battery. When I start the engine, it's going to draw more amps because it's trying to charge that battery and keep up with the electrical demands of the system. In real life at the mechanics shop there, they're going to install the external power supply so that that doesn't happen. All right, now we'll go ahead and turn on the master switch and the avionics. Okay, so the avionics is on. So we're just going to test a few things here. I'm going to look at the knob and see how well that works. So I feel that it's rubbing up against right here. Oh, I've got a floating ground there. And nav works good. You see the flag right there. This is kind of slow. I'd like to speed that up some. So when I turn it back around here, there's the CDI needle, and pretty soon we'll get a 2 flag. We've got the away flag right now. So we'll look here at our second radio stack. So this is our radio selector. This is now on COM1. So we'll go to COM2 NAV2 and we'll check this. See that the CDI does move. As I change frequencies. So let's go with this. And we'll do the same test. Once again, this is really slow. It shouldn't take this long to get through it. There we go. We got the from flag. So I came in here to Notepad++, and I'm going to OBS control, omni bearing selector control, and I reprogrammed those. So there's many ways to code for an encoder, a rotary encoder. And it just depends on the hardware, the software, your interrupts, just your clock speeds, just a lot of different things of how they're going to react. So using different methods to code these gives different results. So it was really slow, and I wanted to speed it up but retain some accuracy. It was also bouncing, which means that if I turned to the left or to the right, sometimes it would go backwards one or forwards one. Not exactly that great for trying to tune things in quickly. And this should solve the problem. So now let's check the OBS to see if it turns any faster. Oh, and look at that. And I also get nice fine control too. Same with this one. Our from and to flags. Looks good. I'm going to check out the flight director and the autopilot. So the flight director is a button up here that I harvested from Lexmark printer. It's got 2 windows in the side of it for LEDs, so I put 2 little green mini LEDs in there, built a little circuit board, and glued it to the back of the panel. It flashes in the on position. When I go to change to auto, it flashes 3 times and it stays solid. Now it is in autopilot mode.
Caution.
And now it's off. So if I click it before those 3 are done, then it's the same as taking the switch, putting to auto, and then putting it back to off. Let's check out the autopilot controls here. So we have our altitude hold, and if I press that, it starts to flash, which is the altitude select. Press it again, altitude hold. There's the heading hold. I'm having to press that a couple of times to get it to work. Same with the localizer. There it goes. And the back course. Now I had to program these all explicitly. There was no pre-programmed code for me. Right here is the heading. I can change that using the heading knob here. Just like that. Okay, so let's check out the code for that here. And this is autopilot control. We'll expand that. And each one of them uses a CommandRef. So there's 3 types of references that tie into the simulator. The first type is flight sim integer, there's flight sim float, and there's flight sim command. The flight sim command is kind of a weird toggle. The first time that it reads through the code, if I have a 1 attached to the command, it toggles it, it turns it on. If the next time it comes through and it sees a 1, it toggles it and turns it off. Sometimes it doesn't cooperate very well. So I'm going to check with ChatGPT and run this block through there and find out if there's something wrong with it. So I decided to feed that autopilot code into ChatGPT to see what it said if I was doing something wrong. And it says that the code looks fine for managing the LED states based on different autopilot states. The logic for flashing LEDs appears correct. Logic for flashing LED multiple times seems correct. The logic for flashing the altitude LED appears correct. Overall, your code appears to be functional for its intended purpose. If you have specific issues or questions, blah, blah, blah. So the only thing that I'm looking at here is you may want to provide more context about what specific issues or improvements you need for this function, for the autopilot control function. Here we are looking at the data ref editor, and I'm using 3D Cockpit to find out what data ref operates the altitude control here. So when I click on this, I see altitude select. Click on it and it's not. So when I press the altitude select on mine down here, this will flash, and then when I press it again, it will stop flashing. So let's look at the data ref for that, and it seems to be altitude hold arm is 1 by default. There we go. And 0 in altitude select mode. I put in some extra lines of code and monitor the state of the altitude armed and hold function of the autopilot. And I wrote this little block of code here to force it to change if for some reason it misses the original trigger right here. I've got a little increment counter here, and I only let it go up to 2. If it goes more than 2, then I bring it back to 1. On the first state, it's armed. On the second state, it's normal. So I looked at the serial monitor here, Alright, so now it's armed. As you can see, it says armed. Press it again, normal. Now it says normal. Press it again, flashes, press it again, and now it'll stop flashing right there. So what happened, the reason it kept flashing after I pressed the button is because the interrupt on the Arduino board didn't catch this command. This was going to keep on flashing until it finally caught up with this entry right here that checks to see if it's still in the previous mode and then attempts to switch it. And it won't stop attempting to switch it until it's finally switched. Otherwise, it just keeps in that loop there until it finally catches it. That's my solution. It seems to work pretty good. There it goes. Turn it off. And after a couple of seconds, it stops. I think that's an acceptable workaround than having to sit there and press it for a few times to get it to stop. It seems to work pretty good. I just want it to be reliable. See, it just caught it the first time right there. And finally it catches it. So it catches it every time. It just might take a little bit before it kicks in. And that's fine. That's acceptable.